In the previous videos, we have already talked about indefinite integration. So if you have not watched that video, you should watch it first. And in this video, we will quickly go through definite integration. So let's get started. So if you have a mathematical expression written like this, f of x dx, and an integral sign is there from a to b, what does it mean? Well, this a is basically the lower limit of integration and this b is the upper limit of integration. Everything else you already know. Then this is going to become equal to capital F of x from a to b, and in the next step it is going to become capital F of b minus capital F of a. So this capital F is the antiderivative of small f. So in case of definite integration, first we get the antiderivative of the function and then we put the upper limit and lower limit and simply subtract it. So the rule goes it like that, so you can see that unlike indefinite integration, here the definite integration of any function is going to be equal to a definite value. This is not a function unlike the indefinite integration. Let's now talk about the rules of definite integration. Well, most of the rules in indefinite integration and definite integration, they are going to be same as far as the integration of the function is concerned. But there are certain rules specific to definite integration. Let's talk about them. For example, let's say we have a function f of x dx from a to a. That means the upper and lower limit, they are same. Then it is going to be 0. Second, if there is a function f of x dx and the limit is from a to b and we want to change the limit, then it is going to be equal to minus of f of x dx from b to a. That means we can multiply the expression with a negative sign by interchanging the limits. Next rule is, if we have definite integral of f of x plus minus g of x with respect to x from a to b, then basically this is also going to follow the distributive property just like indefinite integral. We can write it as integration of f of x dx from a to b plus minus integration of g of x dx from a to b. Next property would be again identical to the property in indefinite integral. Let's say we have a constant in multiplication with a variable f of x dx, then this constant can be taken out of the integral sign, so it is going to become c times integral of f of x dx. Of course, it is from a to b, a to b. And the last important property here would be, let's say if we have a function f of x dx and we want to integrate it from a to b, and c is a number which is between a and b, then in that case we can write this f of x dx from a to b as equal to integration of f of x dx from a to c plus from c to b. So these are the basic rules as far as definite integration is concerned. Let us now talk about the physical interpretation of definite integration. And let's say we have y and x and they are related with each other as y is a function of x and this is the graph of y versus x. So what is meant by y dx integrating from a to b, or what is meant by f of x dx from a to b? Well, it is nothing but area under the curve confined between x equal to a to x equal to b. So let's imagine that this is the line of x equal to a and this is the line of x equal to b. So the area under this curve, which is confined between these two lines x equal to a and x equal to b, is basically the physical interpretation of this expression y dx from a to b. It is equal to area under curve. So in physics, there may be many situations in which we need to calculate area under the curve. All we just need is the relation between y and x. So if we have a relation between y and x, we just need to integrate between which lines we need the area. We just need to put them as the lower limit and upper limit and we can calculate area under the curve. So this is the physical interpretation of definite integration. So this is all about definite integration, and if you want to solve and practice problems specifically related to definite integration and you do not want to waste your time in finding problems in the books or elsewhere, then you can check out my application whose link is provided in the description box below. Thanks for watching.